consulting. We're a litigation consulting shop, much like Econ 1. We actually use R in our day-to-day world every single day. And this is one of our biggest dilemmas at work, which to use. Whether we use Dplyr, whether we use DataTable. With me today is my esteemed colleague, Amy Linehan.
I wasn't expecting applause. Thank you. As Jeremy mentioned, my name's Amy. I've been working on Jeremy's team for 2 years with Ankura. I'm an associate. I actually graduated from UCLA coming up on 2 years, which makes me feel old, with a math and econ degree, so it's nice to come back here. But I actually only started using R about a year and a half ago, so I'm still fairly new, and I definitely started off in the DTplier camp and still primarily use DTplier, but as you'll see today, there's definitely moments where I make the switch to DataTable, and I definitely recommend if you're similar to where I was about a year ago, hang out with Jeremy and he'll definitely convince you to start using some DataTable.
Yeah. So we're going to talk about a few things today. First thing is just what's this debate about? Why do we have this debate between DataTable and Dplyr? We're also going to talk about just the introduction to Dplyr, introduction to DataTable, and then, you know, in the course of our work, we've put together several kind of optimized examples of things that when both packages together kind of work really seamlessly. So, all right. Cool. So these are our two creators. Everyone knows who Hadley Wickham is. I'm assuming he is the understated R god, very influential in the community, very good at tidyverse. It's his baby, and he loves pipes. On the left there, or your right, is Matt Doyle. Who's that? Well, he actually is the creator of DataTable. And you might not know this, but DataTable's existed since 2008. It's been around for a long time, and it's actually a very, very good package. I only got introduced to it recently while studying my master's degree here at UCLA and was immediately turned on to it, flipped it around. I introduced this only because we have two very different personalities. We have Hadley, who's very influential in the community, and we have this man, Matt, who no one really knows who he is, but has done a lot of work to create something very, very useful. Okay, so I know in our keynote speaker, someone said, or the keynote said that, you know, the future data science is sleeping. I had a picture of Homer Simpson snapping at the job. I disagree thoroughly with that because 80% of your day is spent munging through data. And if you can get efficiency and speed gains on that 80%, you can do a lot more work. And this is where we're going to show that DataTable is really kind of the way to go when you have really massive, large data sets. So I actually think the future of data science is actually a lot of data processing, data management, and data analysis, simple data analysis before you get to the more complex analytics, predictive statistical analysis, etc. So we're going to talk about costs and benefits of Dplyr, costs and benefits of DataTable, and how you can maximize efficiency with both using both packages.
So as Jeremy touched on, we're going to start discussing about Dplyr, and we're going to look at why people use it so much and rely on it so heavily, and then also like the downsides and disadvantages that you might come across and why you should be looking to add some different kinds of packages, in particular DataTable, to your repertoire. So obviously the basics, if you've used R before, it should seem fairly simple. You can also get Dplyr just by loading tidyverse, and that comes, we'll talk about that a little later. But essentially what you get in the main packages, if you've used Dplyr at all, you really understand all of this. Pipes, pipes, and more pipes. You look through a script, you open up, you want to know if they use Dplyr, just look for that pipe. Simple, easy to follow code, and then a complete ecosystem of data processing functions. Obviously, as Jeremy's already hinted at, and we'll get into more detail, it is can be a little slow, especially the data that we work with tends to be really massive as consultants. And also, sometimes your code can be really long. So if you're looking for quick, concise code, DataTable definitely has some advantages, and that's where you might want to look to switch. So more specifics, most people here I'm sure have seen a pipe before. If you haven't, it's the parentheses, greater than sign, parentheses, Control-Alt-M is the shortcut in Windows, not sure in Mac. But you can see here on the left is what you would do prior to knowing about a pipe. So you would filter a data to where the value is greater than 100, and you wrap it around your function. That equivalent statement using a pipe would be data pipe filter value greater than 100. And Hadley, being the R god that he is, enlightened us that he thinks it should be pronounced then. So that second phrase would be data then filter value greater than 100. So it's pretty evident that the pipe enables you to link different functions together in different actions, and it really saves you having to save out any intermediate steps. You don't have to be function when filtered, save it out, and then produce and do another action on it. You can instead just keep piping. I know we have some coworkers that like to pipe for hundreds of lines. And one cool thing as a math major that I like to nerd out about is actually the idea of piping doesn't come from R, is seen in Shell and Terminal and other languages. And actually, initially, it's believed to stem from the concept of nesting functions. So in math, you can see f of g of x has the same functionality as f of g of x, and that of is that little circle. And so when you get into really complex math, often we prefer to list the functions out as it's done on the right-hand side. And that same idea is kept in with the pipe. So as a math nerd, every time I see the pipe, I'm like, oh, excited. Little math function. Okay, so moving on. If you've been introduced to Dplyr, when you first were beginning to work with Dplyr, we definitely focused on the 5 main verbs. And I think you can see this example here. Even if you have no experience with programming, you just wandered in here accidentally, you thought you were in dance marathon, but now you're here. You can see, you can read what's going on here. You can say, okay, they're taking a data, they're filtering something, they're group buying, they have a comment there indicating, okay, that's helpful, and then they're going to summarize. I don't know what the end parentheses means. It means counts, the number of instances in that group. But I can kind of get a general idea of what's going on. So if you open up a script and you have no idea what's happening in that world or that universe, you can kind of get a sense when people are using that Dplyr syntax because it's so readable. And Hadley really made that a priority, and when he's been criticized about in this debate of DataTable versus Dplyr, he really highlights its usability and the idea that it's made for the user. And certain things such as the length of the code and the fact that you could do this in one line in DataTable, and also the number of characters you actually have to physically type might be more than other methods, but it makes it so easy for the user. So when you're looking at like a long term, you're coding all day and you're trying to look back on scripts that you've previously written, or you're working like we do in a team of 10 programmers and you're all exchanging code, it's really useful to have this simple code that people can read, especially if they have different levels. We work with SQL programmers who don't see a lot of R code, so having this syntax makes it a lot easier for them to understand what we're doing. And as I mentioned here, there's other verbs. The 5 main ones are select, filter, arrange, mutate, group by, summarize. But there's other ones, mutate at, summarize all, count. If you haven't used them, they're pretty cool. Finally, as I mentioned before, and as I know we discussed previously in different talks throughout the day, is the tidyverse. You don't have to just load Dplyr alone. I actually recommend you don't. I recommend you load in tidyverse, essentially the whole universe of functions. Everything from importing all the way through your execution. You want to add a graph? Do it. You want to add a modeling? Do it. It's easy. It's all in the same syntax. It all relies on pipes. All relies on that readability. And with a little bit of research, you can really get some really great cohesive code throughout your entire script where you're using different functions, different packages with different functionalities. And you don't see that with DataTable. A lot of DataTable users end up having to use different aspects of the tidyverse to get their end result. So here you're kind of staying with the cohesive consistency, as well as just the large community. Like you go on Twitter, you go on Stack Overflow, you're going to see people talking about the tidyverse and different parts, and they're going to say, oh, if you use this, you should use this package in the tidyverse. So it's super easy, and it all together makes it a really readable, really usable package.
Thank you very much, Amy. So now let's switch gears and let's talk a little bit about DataTable. So DataTable has 3 unique advantages. One is significant cost, and if you can get over that cost, then you're great. Okay, so really compact code. So complete departure from what Dplyr does with the elongated code. It's very easy to read. DataTable is very compact. Things that take paragraphs in Dplyr take lines in DataTable. That's why I love it, because I hate to type. So I type as little as possible. I can do a lot of work. Okay, it's pure, unadulterated speed. I don't know how much data people work with on a regular basis. In our line of work, it's tens of millions, hundreds of millions, sometimes into the billions of rows of data. It is always a challenge for us. And so just getting the data into our analysis sometimes takes hours using even DataTable. So if you're using Dplyr and Dplyr functions, it's going to take even longer. We also have much more memory efficiency, so it allows us to keep our systems kind of stripped down and lean, as opposed to having these big bloated systems with a lot of memory. We usually run on multi-core servers with 64, 128 gigs of memory, and even with Dplyr and even that type of space, sometimes we have to manage what we're doing. However, as I said, completely unintelligible syntax. If you don't know what DataTable is and you're looking at the code, you're not going to really understand what's going on. Hopefully this talk will help understand that. But this cost here is huge, and if you can get past it, you can do a lot of great things. Okay, so DataTable is really good for a couple of things. In contrary to the tidyverse, in which you can take some data, do a lot of work to it, manage it, then you can visualize it and process it and do all sorts of stuff. DataTable is really good for data management, data processing. Those are its 2 core functionalities. Those are the 2 things you're going to do the most things with it, and that's where you're going to see your largest speed gains. Okay, the syntax here, totally unintelligible. Data, which is just represents a data frame, I, J, by. I is your filter, not obvious. J is your select, so your variables you're going to pick up, and by is your by statement if you're going to do a grouping by operation. Okay, it also has built-in functions like .n, .sd, .i. .n is like a row count. .i is your row identifier, and all of these things kind of work in concert with each other, but only in the data table universe. Now, the cool thing about what DataTable is doing, which Hadley and DTplier have not done, is they've started to rewrite base R functions. So if you use merge a lot, or use reshape, or if you use the reshape 2 package like we do, like you use melt and decast, they've been optimized for DataTable. If you're in Dplyr, you have to write a whole other set of functions. And so you can actually take existing R code you have right now if you're writing it in base R, throw it into DataTable, and actually achieve significant speed gains by using different functions, using the existing functions that they've recoded. All right, so here's the first step about elongated code. So as Amy described, we have table, filter, group by, summarize, mutate. All of that can be done like this. Now, we also talked about pipes in Dplyr, and he has that little nice piping function. DataTable doesn't have pipes. DataTable, you just take your bracket and you put it next to another bracket. You wouldn't know what that was doing unless someone told you that's what it's doing. But it's taking the output of that first set of commands in which we filter to blue, we do a count by group var, and then we do a percentage. That's the exact equivalent code to up above, where you can see it's much more cleaner and easier to read using the various Dplyr functions. On the left-hand side, same thing. Down below, it's just much cleaner. I like operating in individual lines, and this is much faster. I also want you to notice that on the right-hand side, we don't ever see a piping we don't ever see a redirect operation, a little less than dash, or however, what do we call that in R? Gets. We don't see data like this. Simon, thank you. All right, so why not? Well, because DataTable operates directly on data in memory. It doesn't make copies. And so that colon equal sign there that you see next to the new var, that means it's just making that new variable and assigning that operation directly in memory. It doesn't have to repipe it or redirect it out or assign it to a different data table or a different data frame. Okay, so as I said, pure unadulterated speed. So if you're using read.csv, you're gonna have a lot of fun waiting around. If you're reading read_CSV, it's a little bit faster. If you're using fread, you can load in a 10 gigabyte file in under an hour. Where that same file using read.csv is going to take you 24, and read_CSV is going to take you 6 to 8. It is optimized for loading and writing data. So equivalently, fwrite is the same thing. It's built to write out the data very, very, very quickly. Aggregate functions in DataTable are much faster than Dplyr, and as you can go to the next slide, Amy. As you increase your data set size, DataTable becomes essential. So this very toy example here is a 400 million row data set that we just generated out of random. And we get a 64% faster runtime between DataTable and Dplyr on just that one command. So if you're dealing with lots of data, and we deal with lots of data, we deal with lots of code. We have scripts that are hundreds, thousands of lines long. Each individual speed gain we get from optimizing to DataTable helps us do work faster. And so this is where DataTable has the absolute advantage over Dplyr. It's also more memory efficient. I mentioned the colon equal operator, the set by operation, in which you can operate directly in memory. When you're doing operations with Dplyr and just base R, you're making copies of your data constantly in memory. So it carves out memory, makes a copy, writes to that copy, and then outputs. DataTable doesn't do that. It operates directly on the file in memory. And it's obvious, it's much, much faster.
Okay, so now we're going to review just some examples side by side so you all can see like the different syntax and the different benefits of different particular situations where Dplyr might be more beneficial, or other situations where it's worth to learn the DataTable syntax. Especially, I know from my perspective, I'm looking to combine both of them, and I think that's our end goal argument, is that together they work really powerfully. You don't necessarily need to ditch Dplyr for DataTable and vice versa. So this way you can kind of see situations where you might go, oh, that's a useful place. The first time I saw that was the if-else, which Jeremy showed an example, and we'll show an example. If-else is really simplified in DataTable. So this first example is similar to our previous example. We're just grouping by and summarizing. You can see that there's less words at DataTable and it's shorter, but it's really hard to know what you're doing.
And in this next example, it's the same thing. We're just highlighting, you can sit there and group things together in a similar way as you can with Dplyr. You get the same amount of code, generally speaking, but you don't have as much typing to do.
In here, we're just building on the same example, so you missed the first three. And this last part, we're just filtering. And the part that I find tricky here is just adding on the brackets. I think looks really messy and it's really hard to follow because you don't know what that first bracket's doing, and then it just seems like they tag something on at the very end of the code, whereas Dplyr, it's really clear, okay, this is what we're doing. And here's our final data. Oh, sorry, okay, we're back. Sorry, can't work a computer.
Okay, so I don't know if anyone knows what's going on the left-hand side versus the right-hand side, but that's a join by DataTable. You would never know it from the syntax, but the set key operation orders your data, and so to do joins in DataTable, you have to order, and then you can do your join. But joins in DataTable, by the way, you can just use merge, it works almost as fast, but a pure DataTable join is data1 bracket data2, that's it. And unless you document that really well, you're not going to know what's actually happening with that particular piece of code.
Yeah, and regarding joins, I still always switch back to data frame and do Dplyr because I think it's so much simple. It's so much easier to read, it's easy to remember what I'm doing. Otherwise, I have to comment every time that I'm doing a join, so I don't remember. So here you can see, similarly, we're doing a left join here, and the one key distinction is Dplyr enables you to join on different named columns. So that second column that we're joining on the right-hand side is cap 2 to cap 4. So you might just have different names. A lot of times we see this with like employee names. It might be emp name versus name, employee name versus first name, right, that you're trying to join on. In DataTable, as you can see on number 5, you actually have to change the name of the column and then join on just that one column with the same name. So when you're working on joining on a lot of different columns and things are getting complicated, it's really frustrating to have to keep renaming things. But then, of course, you're sacrificing speed in that.
And here's the if else statement again. I mean, it's pretty straightforward. Again, you don't have the redirect, you don't have the assignment operator, you operate directly on the file. It actually works a lot faster in DataTable than it does Dplyr.
And here, going off what Jeremy's previously said, this is a form of reshape. We're spreading over the data. On the right-hand side, we're using spread, which is one of Hadley's functions. And on the left-hand side, we're actually reverting back to a base R function, so something that you probably learned way back in the day. But it's when you run it, it runs automatically the DataTable version of Reshape. So the syntax might be a little more clunky for someone. For example, I learned spread immediately from day one. It was spread. I never learned the base R Reshape. So for me, the base R Reshape it's not worth it to learn. But for someone who has been using Reshape and has scripts, as Jeremy mentioned, using Reshape, it's much more efficient to just run it with DataTable, where you make data a DataTable and run it, and you'll see a lot of speed gains. Okay, so now we're going to jump into a little real-world example that stems from a case that Jeremy and I worked on last year together. So the timekeeping data is at the top, the user list is at the bottom. So the timekeeping data, we had a client who was being sued by its employees who claimed that they were salaried, they were paid salary, however, their work was hourly, and therefore they were actually entitled to overtime. So the goal was then, okay, how much overtime do they deserve to be paid? If we're paying back, what are the damages in this situation? However, since it's a salary, the company was paying salary, they didn't keep track of timekeeping. It wasn't like you're working at Starbucks and you clock in and you clock out because it's a salary position. So we had to recreate the timekeeping data, and that's what you see a little clip of here. And we essentially used 6 different sources, varying from, okay, when they swiped to enter the building, they swiped to go into the office, maybe they have to swipe to get into the bathroom, they log onto their computer, okay, they use a specific system, the accounting team, okay, they logged onto that system. So we have 6 different sources. Computer logins, also just key card swipes to figure out when were people at work. So for example, you'd see, Fred come in at 8:02 a.m., he swiped into the building. 8:15, he logged onto his computer. 8:30, he switched on to his program. And then he worked on that program till lunch. We see him logging off, we see him logging back on. This was our best estimate to kind of get some kind of timekeeping data. So we ended up with 102 million rows over 6 different sources for about 3,000 employees. And our then next step, because of course, different sources, and it doesn't like to be easy for us, every single source had a different username. So sometimes, A Linehan, or it'd be Amy Linehan, or it'd be Amy.Linehan, Amy Linehan, but it only had the first 4 characters of my last name. So all the different varieties. Sometimes a middle initial was thrown in there because why not? So our next step was to build a user list, and you see that here because our payroll was based on the employee numbers, that's first field. that was linked to a name. Everything else was linked to user codes. So we had to use the best of our ability, involved a lot of like rules in this situation, to build a user list. And so you're going to see in the next couple of slides, we take a bit different pieces of our analysis to show if we ran it fully in Dplyr, fully in DataTable, and then combined the code together using DataTable and Dplyr, how does that change our results when we're looking at 102 million observations, when we're looking at a join. We also do some text parsing and some data parsing. So here at the top is Dplyr. You can see that I have a start and an end at each one, and then the name of the package with the end minus start to get the time. And then I read in the functions using either read_CSV or fread. Then I do text parsing where I extract the date from a date-time object. I mutate it, bring it into a date. Then I bring in the user code to get the employee number. And then the next step in our analysis would be to tack it onto to payroll to find out how much they were paid, to then do like the actual analysis. As Jeremy mentioned, this is like the 80%. In our case, it was like the year that it took to build all of this data. And then the actual analysis ended up taking a couple of months in the end. Like it was a lot marginal. So here you can see Dplyr when I run it, over 6 hours, almost 7. DataTable, an hour. Also, there's a little error. It's actually 6 times faster. That's from a previous note. But you can see that it's vastly faster. And a lot of this speed actually comes from something that Jeremy mentioned earlier, which is the power of fread. I'd really recommend if you're 100% Dplyr, we have people on our team who are like, don't even talk to me about anything else. I love pipes, I love Hadley, I follow him on Twitter. fread is worth your time. I've had a situation like 2 weeks ago where I was waiting forever for something to read into R. It was actually this data set. I was using read_CSV. And Jeremy's like, you're showing fread and you're not using it. And it took like a ridiculously faster amount of time. So I really recommend to look into that. It's simple, it's easy to use. It's essentially the same syntax as read_CSV. And you can see here, that's a majority of the time. And because from what we've known from doing like more in-depth analysis of this, we know that it's better. Dplyr is better at text parsing generally, especially complex text parsing. And DataTable is immensely faster at dates. So knowing that, and there's not too much of a difference in that, like the amount that DataTable's faster in dates is equivalent to kind of the amount that Dplyr excels in text parsing. So it's really that join and then the reading in that DataTable excels. So here you can see our combined example. And now for this, it's a pretty simple example. The only major, we essentially kept the data table because that's the way we ended up doing our entire analysis. And then I put in a Dplyr text parsing because that was the part that was really slowing down the data table. And you can see here, it's slightly faster. It's 1% faster than data table and ends up being 628% faster than Dplyr. It combined for just over an hour. So like the same time that you would run your machine learning. And kind of like Homer, you can sleep while you're doing this. So the key here that I wanted to really highlight was, yes, the combined is just barely faster than DataTable, but we really did keep it simple. One key situation that we found where DataTable just really can't handle is a summarize all, as well as like a mutate all, those kind of situations, where Hadley's really perfected the ability to do similar functions across multiple fields. Really easy, really fast. DataTable struggles. Jeremy did it once in a really, really long piece of code, really complicated, it took forever. And then as well, you also have things like Reshape, where you see, okay, if you already have your code written, you might as well keep it in DataTable. So those situations, if you really add up, and if we had done more complicated pieces of the analysis, you really would see a lot more benefit to the combined method, but I think here it even highlights the fact that if you're using Dplyr, it's worth your time to get DataTable and vice versa, and you should use it together and figure out where's the best moments for you to make that switch. So, any questions?
Is it safer to make a second copy rather than to update it in place like DataTable does?
Well, the copy happens implicitly. You don't see it happening. So when you're doing, like if you're doing an assignment operation into a new table, you're just adding to your memory. So you're gonna, if you have enough memory to handle it, go for it. And yes, that's safer because you can always kind of step back to it. But in terms of in-place operations, if you're reassigning the data to itself, you're never seeing that copy being created. But in the background, it's creating that copy. You can't get back to it. It's all happening in memory, but it blows up the memory, and it's actually really slow because it has to create the copy, reassign, and then overwrite. Whereas DataTable just takes what's in memory and reassigns right directly to it. There's nothing safe or not safe about it. And if you have the memory for it, you should code any way you want to code. But that particular operation is one of the reasons why DataTable is so much faster.
So So are you saying that you were using DataTable to read the data in, but when you needed to like perform analysis, sometimes you were casting it to DTplier and then do it there? Is there a cost associated with doing that?
You actually don't have to do that. There's another package called DTplier. So if you load in order, tidyverse, DataTable, DTplier. DTplier is an attempt to try to meld the two packages together. You do not have to recast to as.data.frame or as tibble or whatnot. You can actually keep it in the DataTable format. Unfortunately, what Hadley has done though, if you pipe things through Dplyr, it will flip it to a tibble or it'll flip it to a data frame, and you have to flip it back to DataTable if you want to keep that advantage. And yes, you're right, there is some cost to going and doing as.dot operations to flip the data, to flip your frames back and forth.
But I haven't found like a real disadvantage where that's a concern. Because I think if you're going to make that switch, you're making that switch for a reason, whether it be syntax or whether it be speed, and it's going to be worth it in the end. So it doesn't take a substantial amount of time.
Yeah.
Yeah.
My question is kind of related to what you guys were just discussing, but what is the community surrounding DataTable like? Because it sounds like Hadley Wickham is the cult leader. He's got lots of followers, right? And they're all real happy with the readability of the syntax that he's created. But what's stopping people from taking the implementation of DataTable and just creating new syntax so that you can achieve the same thing? Is there
Yeah, so Matt Doyle was a finance engineer long ago, and he had to deal with lots of finance data, and he was dealing with, back in 2007 and 8, dealing with tens of millions, hundreds of millions of rows of data, and found that base artists could not hack it. So his package is built from the ground up. And I mean, he has now a development team, and they add things as necessary, but they're really focused corely on, their core focus is simply getting data in and being able to do very simple operations very, very quickly. They're not, I mean, I think what Hadley has done, he's built an ecosystem that you can operate. You can go from the beginning to the end with a visualization all the way in tidyverse. You can't really do that in DataTable. So yes, could Matt Doyle start rewriting things or building things out so it's more like DTplier? It's not really his core focus.
Well, not Matt Doyle, I'm just curious.
Oh.
It's stopping anybody because people contribute.
Yes, and he does have contributors, and I don't know. I'm not really sure. There is a smaller group around them that does a lot of work. Amy, do you have any thoughts?
Yeah, I mean, there's definitely a whole section of Stack Overflow in the internet and Reddit that's diehard, Matt Doyle / DataTable people, and that's their thing. But I definitely, from my experience at least, and I would love to be corrected, I haven't seen the same creativity or ability to be I think a lot of people default to then using DataTable to get their data to a place where then they can utilize more tidyverse situations.
I mean, that's what we do. We don't do DataTable only. We use it for all the data processing, basic analysis, building, cleaning, and then if we're doing visualizations, it's going into ggplot every time.
So I haven't seen a DataTable version of ggplot, exactly.
Yeah,
or a DataTable version of modeling situations.
And I don't think we ever would need to see that actually, the way this is set up.
I guess the root of my question is that I know that they have different syntax, but really it's an implementation and a philosophy where it's Hadley, kind of like someone else mentioned earlier, said you shouldn't destroy data if you're making a transformation or doing calculations on it. You want to keep it so that if you make it, if there's errors, you can roll back, right? Whereas it seems like they're more interested in speed, and which is a perfectly valid thing to value, but it's just a different philosophy.
That's true. I mean, I will say that when we write our programs and scripts and we're doing our data analysis, we always go from beginning to end, so from load to finish. And so we're not stopping and interactively working with our data. So in that regard, we don't really care if something bad happens along the way. We're stopping, going to the beginning and rerunning. There was a question back there?
Yeah, one comment, one question. The comment is just that you can use SatRday with DataTable false to read it in directly to a data frame.
Yep.
Yeah, that's a great note.
Every single time, but I haven't invested the effort to actually learn DataTable despite agreeing with you wholeheartedly. So my question is, how long did it take you to learn, and did you use that course that it pops up and tells you about every time you load that?
Sure. So who here is a UCLA stat major and or grad? All right, cool. So I had Vivian Liu for one class a couple years ago in my grad program here at UCLA, and she spent one lecture on DataTable, and then I kind of spent 2 weeks after that kind of playing around. But we work in R every day, and so it was kind of a building block approach to say hey, let's try something new doing it this way and see where it gets to. And then we were slowly seeing these vast improvement gains. What really keyed us off, this project here was pretty late in the game in terms of our large data. I was working on a project that had 250 million rows of telephone call data. If anyone knows what the TCPA is, you get those bogus phone calls on your cell phone. There's millions of rows, hundreds of millions of rows sitting behind that data, and we had to process it in R, and we couldn't because we didn't have the tools, and that's what kind of really tripped us on to DataTable and trying to do it that way. Like we couldn't even actually, sorry, one more step. We couldn't even actually do any analysis. We'd get the data in and everything would bog down. We needed to use DataTable every step of the way to do anything with it.
Yeah, I think it took me a solid like 6 months to really feel fully, I don't need to be Googling something or referring to other people's, just because I already knew Dplyr, so if I got stuck, I used to just, okay, I'll just revert it really quick, do Dplyr, and then put it back. So it took me a while. It honestly, I was immersed. I would see like the same thing where people are like, oh, I studied abroad in Spain, so my Spanish got better. I just went on a Jeremy case, and my DataTable got better because he would be like, why is this not in DataTable? And then okay, I take it back.
I would say this, I learned in base R and then kind of went, I never really dived deep into Dplyr or the tidyverse at all. I went from base right into DataTable pretty much in that order. And Dplyr has been kind of an afterthought in my career. So that, I think that's a little bit of it, but I don't think it takes long if you just sit there and want to devote right to it and do it.
Yeah, if you're definitely aren't super into Dplyr right now, I really recommend it because then you don't have a default to go back to. Anything else?
No, so thank you.
Yeah.
Just curious, do you guys ever use databases, or do you just do everything in R? Because I mean, you could have it in a database and then use like DTplier if you still want to use R rather than write SQL for a lot of what you're showing.
Yeah, so we do have a humongous SQL mainframe database setup that sits behind a lot of this stuff. It kind of depends on the type of data. R is simply faster, and so we just try to keep it in that when we can. Other cases that we work on, we're in the billions of rows. They have to throw it in the SQL and then carve it out that way, build a sample set, and then push it into R if we're going to do the work in that regard. So we kind of operate with all the tools that are availability. So.